Hi, welcome to the social analytics tutorial. I put together here a Jupyter notebook using Python to show you and showcase a little bit of the use cases and the data available that we've collected in Telegram over the years. Today we'll be looking at a subset of November data over most of the groups that we collect. The idea is that we'll start by looking at the schemas, then we'll do some exploratory data analysis on the data. Learn how to merge these data together because there's messages, chats, and users table. Look at some use cases of what we can do along the way, plot some fields and see some distributions, and then finish up with some more advanced use cases of what you could do if you had access to this social data. So I've kind of rerun the notebook beforehand because there's quite a bit of data being imported here, and some of these cells may take a little bit longer to run for you. But initially, we're just kind of importing some packages that we'll be using in this notebook. This just increases the width of what we can see in the notebook when we're running things. Then we installed Seaborn, and here I'm just updating the gdown package, which is something that would be necessary to download the data. Here we basically download the data from the Google Drive. These are all public files that I've included in a Google Drive, so feel free to download them. Once that is done, you can then just kind of import them into the notebook. These auxiliary functions is just something I've quickly created just to enable us to see the amount of the null percentages within a certain data set. So we'll just move here to the exploratory data analysis, starting with the messages themselves. So the messages kind of look like this. The main fields to kind of look at is the chat ID. So the chat ID is a unique identifier for the chat where the message was sent. Enables you to distinguish between Telegram chats. The ID represents a unique identifier of the message within a chat. So it's useful to refer to specific messages. Date is, the date of the message. User ID is the ID of the user that sent the message, and sender type is the type of the user that sent the message. So it could be, for example, message sender user, which means that it's from the user, in contrast with message sender chat, that could be a message sent from a chat, for example, an announcement or something like that. Then we'll have the actual text, so the text that is contained within the message. Member online count represents the number of members online in the chat at that point in time. Although bear in mind that the Telegram clients can sometimes be iffy about this number, and it takes a little bit longer to receive that number at times. Views are the amount of views that a message left. Again, I would say the same thing about this field. Sometimes I wouldn't find it super reliable. Obviously, a lot of times in a chat with 1,000 participants, you would expect all of them to have views, and you have a lot of messages with 0 views, but we'll have a deeper look into that in a bit. Replies, so the number of replies of a particular message, if someone forwarded them, and the reply to ID. So in this case, if you have an ID in this field, that means that this message is replying to a previous message with a certain ID. This enables you to kind of stitch together different messages that are part of a conversation. Perhaps you can think of it as a sort of like thread in Telegram. So it enables you to kind of create these relationships and follow on conversations. Same thing with replies. I tend to always like to do a describe on each data set. It gives you an overarching view of the distributions. So for example, in this case, we can see that the mean of the member online count is somewhere around 597. So that's what you'd expect of an average group in Telegram. And I'll leave you to see the remaining stats. Another thing that I think important to note is that we have obviously not all fields have a value for every row. So I think it's important to kind of look at the null percentage of certain fields. It gives you a grasp of which fields may be more reliable for you to work with, and some fields that may not be present or may not have values all the time that you can use. I think that's an important thing to do when you start working with data sets. Yeah, so this is currently what you have for messages. Okay, so now we have the chats table. So within the chats table, we have updated and created at fields. Chat ID is it's the unique identifier for the chat, like we previously said in the messages, and can be used to merge the two tables. Then we have the group username, which is the actual username you would see when you're sharing a Telegram and what's present in the link. You'd have a title, which kind of looks like what you're seeing below, so it's a bit more of a visual written way of seeing what the group username is. Whether the channel is public or not, the amount of members in the chat, the amount of members that were online in the chat, the amount of bots within that chat, if the chat has a description, like you can see here, has a bit more long-winded description of what the group is about, the count of administrators, whether how many people were restricted or banned, and finally whether the chat is verified, whether it's a scam or if it's fake. So here you have just kind of like a display of the first 5 values within this table, and then finally you also have a describe showing you distributions and more or less the average of some of these values. So nice to note that, for example, member online count on average, you have 220 people online. You tend to have around 3-4 bots per group, and yeah, not many administrators, if any. Same thing with restricted account and banned account, which are kind of fields that are rarely populated. And you can see that by the null percentages. Obviously here will just show you the nulls, but then if you investigate a little bit further, you can see that these values are often not there. So that's kind of like an overview of the null percentages, and then I've included a bit of code here to also show the distribution of member counts. So not surprising to see that most of them are kind of in the lower bound of members, and then also the same thing with bots. So as we saw the distribution before, you only tend to have 3 or 4 bots per chat, which tends to be the automated bots that you see on Telegram, whether they're there to automatically answer people's questions or whatever, or to kick people out if they're spamming. But a lot of Telegram's groups tend to have a few in-house bots to kind of for housekeeping purposes. So here we have the users table, which consists of the user ID, which is the unique identifier of the user. Then we have the first name and last name of the user, if they wish to insert that data. Then we have the username, which tends to be what people kind of remember within the Telegram world. Then we have a few flags indicating if the user has been flagged as a bot, if it's been verified, if it's either a scam or fake user, and finally the created at and updated at fields. This is just a sample, so five rows of what the table looks like, and again the described showing a bit of the distribution of these fields. And finally we have just a printout of the null percentages of these fields, and expectantly so, as Telegram tends to be more of anonymous worlds, the actual first name and last name are the fields that exist less. So that's just something to take into account. Moving on, then we have a bit of code on teaching you how to merge these 3 tables. The main fields that we need to think about are the chat ID and user ID, right? So if you want to merge the messages to the users table, then we use the user ID as the field to merge those tables. If we are trying to merge messages and chats, we would then use the chat ID to kind of merge those tables together. So in this first example, we're just trimming a bit of the if users, because I don't really want to, I'm not interested in the created at and updated at columns, for example. And then I'm going to go ahead and merge those. This is kind of what it would look like as an output. So now not only we have the messages, but we also have some more information about the user that posted this message, which is kind of useful to know. For example, here we have a user that posted, and we can see that this user has been tagged as a bot. So you could immediately tell that actually this message has been sent from a bot and not from a legitimate user, for example. Then I've included a bit of codes to just print out some percentages. So the idea here is just to show what percentage of these fields are either false or true, enabling you to kind of see that, 84% in example here, 84% of the users are not tagged as a bot, and 15% of the users are tagged as a bot, which is actually quite high if you think about it. 99% of the users have not been verified, and also are not scammers, and there isn't in this dataset any users that have been tagged as fake in this particular one in November. And then moving on, we have an example of distribution of message counts per user, showing you that most users are not posting that many messages, but you do have it declines fairly quickly, but you still do have a respectable amount of users that do message a lot. Bear in mind that where I'm hovering in my mouse is around 1,000 messages, so there are quite a lot of users that are very active, or are simply bots or spammers. So putting together all this information, there's already quite a bit that you can think of. I put here a few descriptions of a few questions that I would like you to think about, or basically food for thought, right? Some of them including whether we should cleanse or remove these messages from bots that are scams or fake users. Now that we're able to kind of merge these two tables together, depending on your use case, you may be able to not want any of the messages that belong to scam bots or fake users, or maybe actually what you want to look at is specifically the messages that are being spent by bots or scams or fake users. So that's something to take into consideration. Then there's plenty of other stats that you could get from this data. How often is the user messages within a chat? Are these user activity above average of all the other users? Potentially that could be a metric, whether you tag the users with some more in-depth information. Maybe you could classify users as active users, low users, spam users, or potentially bot users, things like that. It opens a whole new world of what you desire to do with the data, essentially. It also enables you to define which users are the top users within a particular chat. So you can do that across the whole Telegram world, because we index so many of the Telegram groups that are related to crypto. But you could also narrow down that analysis to a particular chat, and maybe create a ratio and find out what are the top users of a particular chat, and why that may be important or why that may be not important. You could also use the reply fields, be a good way of keeping track of conversations or strings of conversation, or maybe a metric of engagements over impressions, right? If there's a lot of replies, a lot of views, a lot of forwards, a particular message, that means that it's gonna reach a lot more people, and that may be something that you want to know for your particular use case. So all these things are things that I think are interesting to think about, and it really makes your brain think about all the potential avenues that you could take when you have this data on hand. Now we can have a look at how we would merge chats and messages. So previously I was saying that, if you want to merge messages and chats, you're probably interested in using the chat ID as the merging key. And before we do that, we just use the fields that we're interested in keeping. So in this case, we kind of removed updated ads and created ads from the chats table, as it's not really something that I'm interested in adding on. And then once we merge them, this is more or less what it looks like. You have essentially gained a bit more information on the messages, including the group username, the title of the chat, and a few more things like the bot count, if it's verified, if it's a scam, or if it's a fake. So that could potentially add a bit more information if you want to know more about the chats. And then the rest is a bit more imagination. Maybe you have calculated a few metrics about a particular chat, so you could append that to the message, so it's easy for you to associate those chat statistics with the particular message or the user that is sending. So those are other things you could think about. Next, I've included a bit of code to show the distribution of member online counts across all messages within this period. And not surprisingly enough, right, like most of the distribution is skewed, and most of the groups would be kind of below 1,000, right, in terms of member online counts. Next, we have merge users, message, and chats. So maybe you could have a particular use case where you want to merge everything together, where you want to have access to chats data, users data, and messages enhanced data. So you can kind of put everything together. Obviously now the data set starts becoming like quite big. There's a lot of rows to take care of. So that's something to take in consideration. But a use case that I put here as an example of what you could do with this is once you have all the data merged together, maybe you could group by all the data by chat ID and count the percentages of this chat stable. So within each chat, you would have a percentage of users that have either been tagged as a bot or verified or scam or whatever. And it can give you, or you can gauge a little bit of the percentages of users within a chat that are bots. One particular one here that pops up, for example, is this particular chat ID, where 40% of the users are bots. Obviously, this wouldn't be a very good sign, for example. I don't really have any more information that I've aggregated here. Maybe this chat there's nothing more here. There's not many users or people chatting, which could be responsible for such a high number. But yeah, it gives you the opportunity to kind of put all this information together and do the analysis and explore the insights that you're looking for. Moving on to measuring chat activity. This is one I particularly quite like. I think the power of having all these Telegram groups indexed is that you can actually have a look at the overarching, or what I mean to say is an holistic view of everything is going on. And here, over the course of days, you can count the number of messages that have been posted on a particular group and the number of unique users that have chatted on that particular group, which in my opinion is a much stronger metric than, for example, member online counts, where maybe you could have had quite a lot of people online, but not a lot of them are participating. When you have groups where there's a high count of unique users participating, it really gives you an idea that there's a lot of conversation happening, and that tends to be valuable when looking for signs. Another thing that I think is quite good is that you can slice this data set essentially for the project that you're looking for. In this case, we're looking at the Taraxa project, and we can see how it evolves across a particular month. In this data set, we have the month of November. So we can, just looking at the table format, you can see that there's a large increase in attention around Taraxa, and then a large decrease over towards the end of the month. And when we plot this data, it becomes obviously a lot more evident. There you see this giant peak here in the middle, around 17th of November. Moving on, we can do the same thing, flipping it from chat activity but to user activity, right? So in this particular case, I've aggregated the user activity over the course of this month, and then we can I've sorted it by number of messages, so users are particularly that are chatting a lot within this time period. And when you kind of sort them in this way, you can see that immediately the first user that appears on any particular day, I mean, is messaging more than 15,000 messages on a day, and participating in more than 1,000 chats, right? These are really large numbers. Is this activity really legitimate? Is this actually a user or a bot or something else? My take is it probably is not a user. I don't think anyone would be able to text this much. So these are kind of things that you could you can look at. Maybe you could define some thresholds where you think, you know, above this threshold, it's probably not a legitimate user, or what I mean is an actual user, a human like you and me, posting messages on Telegram. So those are other things that you can extract by using user IDs merged with messages. And then finally, I just wanted to have a look at Taraxa users. So here within the full merged dataset, I'm isolating the Taraxa project and looking at the user ID and do value counts, which basically will show you how many instances they showed up in the data. So this basically will give you 15th of the most active users within the Taraxa Telegram group. We then grab their IDs purely for the intention of then kind of plotting them or identifying them within the statistical data sets that I created here, which puts everything in user ID, date, and then the respective messages, chats participated, and the group usernames that it participated in. So this is quite interesting. You can see that, for example, one of the most active users in Taraxa is unlikely a human, because, you know, he's texting more than 15,000 messages a day and participating in a lot of chats, over 1,000 in a lot of the days, and then quickly kind of the distribution dies off slowly, dies off quickly, indicating that, you know, this is probably not the general behavior that you would see in the Taraxa project Telegram group. And what's left interesting to note is that, you know, you do have some users that are frequently messaging several times a day, and a lot of these users are actually quite focused within the Taraxa project. You can see that it's either a Taraxa project or the prize talk. Some others have participated in other groups. So for example, this person is in the Taraxa project, but is also talking in Phantom Protocol, in the Caspa, BTC Station, and Myria project. So you can kind of see how this would be useful if you were to do this in mass, right? Because you can start creating relationships between the most active users or users that you want to look at in a particular chat, and link them to other chats in which they're participating in. If you wanted to go more in depth, you could also start looking at what they're talking about and what conversations they're having that link different Telegram IDs together. Those are other things, other food for thought to think about here. Okay, now we're gonna move on to calculate mentions of a particular project across Telegram groups. So here again, I'm isolating the Taraxa project, where we have the actual project name and then the ticker for the symbol. So I'm gonna just do a simple, basically regex, where I'm just gonna look for any instances where either Tara or Taraxa is mentioned. And as you can see, I'm just gonna search and highlight, for example, Tara, and you can see that it's basically identifying any substring or any instance where either Tara or Taraxa is mentioned. And it's quite evident to see that some of the times it's not really what you want to capture. For example, here there's a tag of a username that's called Tara's, and therefore it's identified as a mention, and it shows up in some of the words or mentions that other people are talking about. Another thing I've noticed is, for example, Tara is, I think, a Hindu word, so it shows up a lot of Hindu text. So yeah, this is clearly not something that is desirable. So I kind of wanted to use this to bridge this points to the idea that it's probably a good idea to cleanse the data, and that's the next session I wanna move on to is what kind of cleansing you should do to the data, and what steps you could do to clean this out, so it's a lot easier to analyze and you don't end up with situations like this. So this brings us up to the cleaning stage. So I've written here some ideas and bullet points of things that you could remove, and are quite common to remove in natural language processing or when dealing with text data. These particular ones at the top are quite useful for social data. So, you know, in social data, there's a lot of emojis and links that people are sharing. That is not that common in traditional analysis of text. For example, you know, large books or news from newspapers and so on. These weren't so prevalent, but in social data is something that I personally think it's quite essential, unless you're doing some kind of use case where you want to keep the URLs and you want to see what people are searching, maybe to scrape some data or whatever it may be. But in this particular case, we will do a few of those. So I think we'll remove emojis, URLs, and then tokenize the data and use the NLTK package to kind of do the remaining cleansing for us. One thing that I highly advise to do when starting to do that is using Pandarel package. Sorry, hard to pronounce. This will enable you to tap into multiprocessing for pandas data frames, which really speeds up the computational time. Bear in mind that the amount of data that we put out in public is in several of millions. So depending on the laptop you're using, this will take some time to process. And by using this package, you will speed up that time by a lot. In my case, I have 10 workers or 10 cores in my computer, so I can enable those 10 to work at the same time. Here I've pre-run everything. So we're taking the text data from messages tables and creating a new field called clean text. So we're passing the output from this remove emojis function into this clean text field. And as you can see, after it's been done, on the left-hand side you have the clean text, on the right-hand side you have, I guess, the raw text. And you can see that some of the emojis have already been, so all of the emojis have been removed, which is exactly what we wanted. Next we have the removal of URLs. Similar thing, I've included a bit of regex to remove these URLs as an example, and then once you remove them, the URLs will be gone. And finally, we have clean and tokenize. So word tokenize here is a function imported by the NLTK package, and this will tokenize the text, and then from these tokens we'll only keep alphanumeric values, so either a number or a letter, and we'll return those. So in the end, once we've tokenized this data, we end up with these three fields that I'm isolating here, and you can see that we started from raw text where there's emojis, URLs, and so on, and then moving on to clean text where it's not completely clean, but you can see that there's no more of these URLs, there's no more of these emojis, but there's still some /n's and things like that normally indicate a new line or whatever it may be. And once you move to tokens, like those are also gone. So this enables us to have basically a data structure that is really easy to isolate particular mentions of what people are talking about. And if you do this preemptively, it really speeds up the computing when you're looking for stuff. So that's a little tip right there in terms of cleansing. So now that we have cleansed the data, I feel like it's a good idea to rerun the mentions over time. To isolate the mentions of a particular project over time in the messages, and we're doing similar exercise. We're isolating within this tokens field any mentions of either Tara and Taraxa. So now we would avoid instances where the partial match of Tara and Taraxa won't be matched to a particular message on Telegram, and it will only be matched by the single use of the word. So once that's run, we can see what it looks like. So we would have a double index data frame where we have the mention that we want to capture, and then the date in which that happened and how many times it happened. Again, not only across the Taraxa project Telegram group, but across all projects, all Telegram groups, or all Telegram groups that we index in this case. And then once you have that, it'll be interesting to kind of plot that in using matplotlib. And once we do that, we have a nice chart showing us the instances of people talking about either Taraxa or Tara over time. And similarly to what we saw before, we see a large spike around the 17th, 18th. So I'll leave you with that. And then I would highly advise you to potentially import some data from CoinGecko or whatever aggregator you'd like, and superimpose that price data on top of the mentions. And yeah, let us know what you think, if you find anything interesting, and come back to our Taraxa social channels to discuss about it. Finally, want to leave you with one last section, going a little bit more on an advanced use case, I guess, using sentiment analysis on the messages themselves. I'm here using a popular repository where people put their models or data sets, and it's all open source, so anybody can go and pull these and use them. To do this, we need to just install transformers. So we do that in this line here, and then once we have that, I'm basically importing this particular model called Bird Suites based sentiment analysis, and you'll be able to find this in the Hugging Face. In fact, I think I put a link here where it will directly link you to models that are around sentiment analysis within Hugging Face. So as you can see, you have a lot to choose from and to try out. Some are tuned to particular use cases more than others. So just give them a review and decide which ones you want to try out. In this case, I just went for this one here. Here I'm just doing a little test. I love using transformers. They make NLP so easy. And the result is that it's a positive message, right? So in this particular model, it's a classification model, and you only have 3 outputs. It's either positive, neutral, or negative. To show that a little bit better, I put some example messages here and kind of run them through the sentiment analysis, and you can see that, for example, I love Taraxa. I'm going to run my own node and stack Tara. That has a high positive score, 0.99, which is good because the message is positive. I have never heard of Tara. It seems like I have missed the train. This has been tagged as negative, because obviously there's negative connotations to the message, but anyone that can read this could potentially see this as positive. So it's an example of how these models are not always accurately going to predict exactly the sentiment of a message, but it does a fairly good job at doing that. Another example is when is bridging going live. That's been tagged as neutral. And finally, meme coins are rallying like crazy, which has been tagged as a positive sentence. And then I wanted to finally just run this model through a sample of messages that have been posted on Taraxa project, and here you can see the outputs of them. So you have the text data, the clean text data, and then the sentiment score that has been associated with that particular message. And you can see here that the model sometimes struggles to allocate whether something is positive or negative, and simply goes for neutral, which a lot of these messages, to be fair, are. But feel free to go through them and see whether you think this model is working well or not. If it isn't, then you could try another one, or use this particular data to actually label some data of what you think is positive or negative, and then retrain these models and use your own machine learning model that has used kind of like this real life data that you can annotate and get better results on ultimately. And then lastly, I'm just kind of counting the overall sentiments that was observed in these subset of November messages, and we can see that overall most messages have been neutral, with slightly some more positive than others. But obviously I think this is a sample of 50 messages, so it's not really a good sample of I guess, for example, what people are thinking of Taraxa. It's just a tutorial to show you, how to do things and what you can do with this data. So that kind of finalizes more or less what I wanted to show, or some of the use cases that I wanted to go through. And I just wanted to leave some finishing thoughts. So here I've included some use cases to potentially try out if you really wanted to dig deep into this data and potentially create a product out of it, or simply just for fun. Some notable things that I think would be really useful and really interesting to do with this data. One of them would be to create a graph, so graph-based data analysis. Here you could construct an integrated graph using the user message and chat data to uncover insights and hidden patterns in the relational data. So as we saw previously, we have fields such as reply to ID, forwards, reply, and you can use those to kind of link up who's replying to who. If that user ID is talking in a particular, for example, the Taraxa project, but is also talking in another project, those things could be interesting. You know, for example, if you're someone that is really into meme coins or whatever, you could look at the top users that are talking about Doge and seeing what else they're talking about, because that you might uncover new meme coins that are coming out or something like that. Next, we have named entity recognition models. So those are notably used to, for example, in an LP, you want to categorize a particular word being an organization or people or a verb or an adverb or whatever categorization you want to do. And here, there aren't many models in crypto where that are able to do this. For example, you feed it a message and it would categorize particular projects as being part of the RWA narrative, or is it a layer one, or is it a gaming project, or whatever it may be. You could also isolate particular project names that people are talking about, or organizations, or people. For example, if a lot of people are talking about Vitalik, you could have a model that understands that Vitalik is a personality or high profile figure in crypto. Or maybe you would find that they're talking about Stephen Poo, which is the CEO of Taraxa. So there's plenty of use cases here where you could do this if you have access to this kind of data. Moving on, we also have more advanced use cases, which would be actually tuning a large language model to complete specialized tasks within the crypto domain. This is something that's actually been done quite a bit recently within the crypto realm, where a lot of projects are spinning up with their own large language models, where they've trained them for specifically crypto chatter, and they've achieved quite high performance in doing specific tasks within crypto. Notable, the ones that I've seen the most are large language models that have been trained with a lot of documentation about crypto projects, and they're able to automatically answer questions that users may have in Telegram using these AI models. And finally, you can also do maybe some topic modeling about crypto conversations, right? You could analyze, 100,000 messages, and within those 100,000 messages, you could categorize them into topics. So then you can, for example, plot the attention that is surrounding particular topics within the Telegram realm, and analyzing all these thousands of groups, you'd be able to get a really good holistic view on which particular topics are hot at the moment, what's decreasing, what's increasing, and have a better perception of what is going on. And finally, I would invite you all to try this notebook by yourself. I'm going to share this in a Google Drive along with the associated data. And let us know what you build, and please come talk to us in all our Taraxa social channels, and look forward to talk to you.